Welcome to this comprehensive and deep dive into JavaScript strings, arguably the most common data type you will manipulate as a professional developer. Whether you are processing user input from a dynamic web form, formatting complex data for a clean user interface, or parsing extensive text files from a back-end server, mastering text manipulation is absolutely essential for your success. In this targeted session, we will explore the fundamental nature of the string type, completely unpacking its immutable sequence architecture. We will rigorously cover the myriad ways to create and combine text, delve into the flexibility of template literals for dynamic content generation, and examine the extensive built-in methods available for searching, slicing, and transforming your data safely. We will also touch upon the nuances of the Unicode standard, including how emojis are processed under the hood. Let us begin. To understand text in this language, you must first grasp its core architecture. A string is fundamentally an ordered sequence of 16-bit values, utilizing the UTF-16 encoding standard. Crucially, this sequence is zero-based, meaning the very first character always resides at index 0, just like elements within an array. However, the most vital concept to internalize is that strings are completely immutable. Once a text value is created in memory, it can never be changed in place. Any operation that appears to modify the text actually creates and returns an entirely new sequence. You must also be highly vigilant regarding a common Unicode trap. While standard alphabet characters occupy a single 16-bit unit, complex characters like emojis often require two consecutive units, known as a surrogate pair. This means a single visual emoji might surprisingly report a length of 2, not 1. When you want to inject raw text directly into your source code, you write a string literal. The language provides you with three distinct delimiter options to enclose your text: single quotes, double quotes, and modern backticks. For standard text, single and double quotes function identically, giving you the flexibility to choose based on the content itself. For example, if your text contains HTML attributes wrapped in double quotes, enclosing the entire string in single quotes prevents syntax conflicts and keeps your code perfectly clean without requiring escape characters. Backticks, introduced in modern syntax, offer specialized superpowers like native multi-line support, which we will explore deeply later. For older code bases using standard quotes, creating a multi-line string requires explicitly placing a backslash at the very end of each line to tell the parser that the text continues downward. There will be many times when you need to include characters that cannot be simply typed on a keyboard or would otherwise break your syntax delimiters. This is where escape sequences become indispensable. By using the backslash as a special trigger, you instruct the engine to interpret the following character differently. For instance, a backslash followed by the letter N inserts a line break, while a backslash followed by T creates a horizontal tab. You also use this mechanism to safely include quotes within a string delimited by that exact same quote type. Beyond simple formatting, this escape syntax is your gateway to the full Unicode universe. By typing a backslash followed by a U and a specific hexadecimal code, you can render any global symbol, copyright mark, or mathematical operator perfectly, ensuring your application can display rich international characters even on restricted systems. One of the most frequent operations you will perform is combining multiple pieces of text into a single cohesive message, a process technically known as concatenation. The simplest and most historic way to achieve this is by utilizing the standard plus operator. When the JavaScript engine sees the plus sign between two string values, it seamlessly fuses them together end to end. As you dynamically build these combined messages, you will constantly need to verify their size. Every string automatically exposes a length property, which instantly reports the total number of 16-bit units it contains. An empty string, represented by two quotes with absolutely nothing inside, will rightfully report a length of 0. Understanding how to smoothly glue text together and immediately verify the resulting character count forms the bedrock of building dynamic user alerts, constructing URLs, and formatting output. Analyzing and dissecting text is a daily requirement, and the language provides a robust toolkit for these tasks. When you need to extract a specific portion of text, the slice method is your most powerful ally, allowing you to snip out a substring by providing starting and ending indices, even supporting negative numbers to count backward from the end. For locating specific content, you have several highly optimized methods. The index of function scans the text and returns the exact numerical position where a target word first appears, or a -1 if it is completely absent. For locating specific content, you have several highly optimized methods. The index of function scans the text and returns the exact numerical position where a target word first appears, or a -1 if it is completely absent. When you need to extract a specific portion of text, the slice method is your most powerful ally, allowing you to snip out a substring by providing starting and ending indices, even supporting negative numbers to count backward from the end. For locating specific content, you have several highly optimized methods. The index of function scans the text and returns the exact numerical position where a target word first appears, or a -1 if it is completely absent. Modern syntax also blesses us with the includes method, which provides a straightforward true or false Boolean answer if a phrase exists anywhere inside. Furthermore, tools like starts with help you quickly validate if a sequence begins with a specific pattern, which is incredibly useful for parsing specialized data formats. Transforming text to meet your application's specific formatting rules is effortless with the built-in modification methods. You will frequently encounter user input plagued with accidental invisible spaces at the beginning or end. The trim method cleanly strips all this excess white space away, leaving you with perfectly sanitized data. For standardizing comparisons or enforcing a specific visual style, methods like toUpperCase and toLowerCase instantly shift the casing of the entire sequence. When you need to swap specific words or correct targeted typos, the replace method steps in to swap the first instance of a target phrase with new text. However, you must constantly remember the cardinal rule we established earlier. Strings are strictly immutable. None of these transformation functions alter the original variable you called them on. Instead, they generate and return a brand new, modified text sequence. Modern development often requires precise visual formatting, especially when dealing with tabular data, financial numbers, or terminal outputs. The language now includes dedicated methods to handle these layout challenges effortlessly. The repeat method does exactly what you would expect. It takes a string and duplicates it a specified number of times, gluing the copies together perfectly. This is wonderfully efficient for generating separator lines or indentations. When you need to ensure a string meets a specific minimum length, the padding methods are invaluable. By using pad start, you can force a string to reach a certain size by adding specific characters, like zeros, to the very beginning, which is the standard technique for formatting digital clocks or receipt numbers. Conversely, pad end adds your chosen filler characters to the right side, ensuring your text aligns perfectly in structured columns. Because a string is fundamentally an ordered sequence, you can interact with it very much like a read-only array. If you need to isolate one specific character, you can use standard bracket notation, placing the desired zero-based index number inside square brackets directly after the variable name. Alternatively, you can use the classic char@at method to achieve the exact same visual extraction. But occasionally, you need to look deeper than the visual representation and uncover the actual numerical code that the computer uses to store that symbol. For this low-level inspection, the char code at method is available, revealing the precise 16-bit integer associated with that position. While these tools are excellent for basic alphabet characters, you must remain cautious when dealing with complex modern symbols like emojis, where you should prefer newer methods designed specifically to handle surrogate pairs safely. The introduction of template literals revolutionized how we construct dynamic text. By utilizing backticks as your delimiters instead of standard quotes, you unlock incredible new capabilities. The most powerful feature is string interpolation. Instead of clumsily gluing variables and raw text together using the plus operator, you can now seamlessly inject JavaScript variables or even complex mathematical expressions directly inside the string using the $ and curly braces syntax. The engine automatically evaluates the expression and embeds the result perfectly. Furthermore, template literals natively support multiple lines. You can press Enter and format your text with visual line breaks and indentations directly in your source code, and the final string will respect that exact formatting. This makes generating complex HTML blocks or long dynamic system messages infinitely cleaner and easier to maintain. When simple searching and replacing is not powerful enough, you enter the domain of regular expressions. This is an advanced pattern matching language built directly into JavaScript. Instead of searching for a static word, you define dynamic rules, created by writing specialized syntax between two forward slashes. For example, you can write a brief pattern that strictly identifies any continuous sequence of digits, regardless of what the actual numbers are. You can enhance these rules with powerful modifier flags, such as making the search entirely case-insensitive, or instructing the engine to find every single match globally across the entire text, rather than stopping at the first success. When you combine these intricate mathematical patterns with the string's native match or replace methods, you gain the supreme ability to parse, validate, and comprehensively reformat massive blocks of complex data instantly. We have successfully traversed the extensive capabilities of the string data type, equipping you with the vital tools for expert text manipulation. You now understand that text is a completely immutable sequence of values, requiring you to capture the results of your transformations into new variables. We explored the flexibility of modern backticks for clean variable interpolation and multi-line formatting, which replaces the tedious concatenation of the past. You learned to wield a powerful arsenal of extraction and inspection methods, enabling you to slice, trim, and search through data with absolute precision. We also highlighted the hidden complexities of the Unicode standard and introduced the unparalleled pattern matching power of regular expressions. Armed with this comprehensive knowledge, you are fully prepared to tackle any text processing challenge, ensuring your data is always pristine, formatted, and accurate.